Hello. Our final topic for chemistry is going to be acids and bases. All right. Acids and bases are going to become important when you take anatomy and physiology, because in terms of blood chemistry, if the blood becomes too acidic, that can essentially result in death. Same thing if the blood becomes too basic, okay? So it's crucial for the body to be able to control how much acid, how much base is circulating within the bloodstream, okay? And in terms of what an acid and what a base is, okay? An acid is going to be any compound that releases a hydrogen, okay? That hydrogen is going to essentially lower the pH, because pH is going to be how we're going to detect changes and whether or not something's acidic or something's basic. I've got over here the pH scale. I'm going to explain that here in a minute, okay? First, I want to define what what an acid is, okay? A base then is something, a compound that is going to accept a hydrogen, okay? So our pH scale, what that pH stands for is the potential of hydrogen, okay? And it's typically written this way: the P is lowercase, the H is capital. All right, and in terms of our pH scale, we've got a range that we grade things on, all right? All the way out here at 14, this is going to be basic, all right? And really anything between 7 and 14 is going to fall into that category, okay? Down at 0 here, this is going to be acidic, all right? Again, anything between 0 and 7, this is going to register as something acidic on our pH scale. All right. If you noticed, I did this in reference to 7. 7 is considered neutral. All right. At pH 7, you have an equal amount of hydrogen released, equal amount that's taken back up. So as far as that balance goes, all right. So 7's neutral, all right. Most of your body is going to fall in and around neutral, all right. Now in terms of that pH scale, we've got 6, 5, 4, 3, 2, and 1, okay. You notice we're moving in units of 1, all right. But with the pH scale, one of the things you want to pay attention to, the pH scale, while you're moving in units of 1, that pH scale is actually logarithmic, which means a change in pH from 7 to 6 is actually a 10-fold increase in the amount of acid in that particular environment, okay? So in terms of that, you don't just have one time as much acidity. 7 to 6 would be 10-fold. 7 to 5, 10 times 10, you've got 100-fold more acidic environment, okay? And you can keep going, okay? Each of those intervals you can think of as a power of 10, okay? And that's true also on the basic side. 8, 9, 10, 11, 12, 13, okay? Now, in terms of normal body chemistry, most of the body is going to fall in between a pH of 6 and a pH of 8, all right? There is, because we're talking about biology here, well, we're talking about chemistry, but we're talking it in context of biology. There is an environment in your body that is highly acidic, all right? Believe it or not, you have a giant bag of acid sitting inside of your body, and your body has adapted to deal with that, okay? So in terms of that, where we've got a low pH is going to be in the stomach, all right? The pH of the stomach runs in and around about a pH of 2. And what's amazing about the body is the stomach has adapted to be able to deal with that highly acidic environment, okay? So in terms of that, most of the body is going to fall into a pH range of 6 to 8, okay? Urine and the sweat on the outside of your body usually runs somewhere between pH of 6 and 6.5, okay? Your blood is actually very tightly controlled, and it doesn't dip much below 7 or much above 7. It's really, really tightly controlled, and you'll learn more about that in anatomy and physiology. But the blood is going to be neutral, okay? So in terms of that, and with the pH scale, I want you to understand when you're going to a smaller number, if you're getting smaller than 7, that particular solution is going to be considered more acidic. If you're higher than 7, it's going to be considered basic, okay? So in terms of the pH, that's why it's important that you understand what pH is. Acids are going to release a hydrogen. Bases are going to accept a hydrogen, okay? In terms of that, hydrochloric acid, which is actually the acid that is found within your stomach. You have cells within your body that produce hydrochloric acid, all right? It releases that hydrogen. The hydrogen is what lowers the pH, okay? Likewise, you've got bases. Bases are going to accept hydrogen. Sodium hydroxide is an excellent example of a base, all right? And in terms of that, what's holding this together, because we've got sodium in there, it's fairly easy to break off the hydroxyl group, which is the OH, from the sodium, all right? That hydroxide group then is going to be what accepts the hydrogen, and that's going to generate water, okay? So in terms of that, bases are going to accept hydrogen. Sodium hydroxide, great example, all right? And I'll label this because I haven't talked about functional groups. And OH is considered a hydroxyl group, okay? That hydroxyl group, because it's going to have a slightly negative charge, because remember, oxygen is slightly electronegative, it's going to sop up any free hydrogen that happens to be around, and that'll get our pH to move more towards the basic end of the spectrum, okay? So in terms of that, I've got a couple examples in the PowerPoint about acids and bases. One of the examples I've got in there talks about acid and the environment, all right? You may or may not be aware that rain over time is becoming more acidic, all right? And it's becoming more acidic because of the pollution that we put up into the atmosphere. When that water or that rain comes down, it's picking up those free hydrogens and resulting in essentially rain that's more acidic. It's bringing down those hydrogens, and that's destroying certain parts of the environment. In particular, lakes and ponds are very sensitive to acid-base levels. You're going to have certain organisms that are going to be able to survive around neutral. If it becomes more acidic, those organisms are not going to be able to survive, okay? So acid rain is one example of where acids and bases are important in your day-to-day life. The other example I have there is with human health, all right? In terms of human health, because of the acid rain, we're actually inhaling more of that acidic atmosphere, and that's creating some health problems, particularly with the lungs, okay? We're seeing increases in disorders associated with the lung, like asthma and bronchitis. It may be that the acid environment is a contributing factor to that. It may not be the sole factor, but it's contributing to it, okay? So in terms of chemistry and what we're going to do in this class, I don't want you to be intimidated by chemistry, because really you have been doing chemistry really your whole life. You just weren't aware that you were doing it, okay? So in terms of that, acids, bases, if you have any questions, please let me know. Thank you for your attention.